Hey there, this is Mathcamp321, and this is another installment of a video series on logarithms. This particular video is part 4 and discusses condensing logs. In this video, we're going to be exploring condensing logs. The three log properties discussed earlier can be used either forward or backward. Here are the properties again, but this time in reverse. If we look at the product rule in reverse, we see log A plus log B is the same as the log of A times B. Notice we see the word log twice in the given, but there's only the word log once in the result. Let's move to the quotient rule. If you see log of A minus log of B, this can be condensed to the log of A over B. Again, we see two occurrences of the word log in the given, but only one occurrence of log in the result. And finally, we have the power rule, and that is if we see a coefficient n in front of a log expression, that coefficient can become the power of the argument. So n log a becomes log of a to the power of n. Let's try a few examples. Use the properties of logs to condense until a single log expression is achieved. This process is called condensing. Strategy: use the Power Ranger rule first whenever possible. So in number 1, we're asked to condense 2 log x plus 2 log y. If we use our strategy in using the power rule first, we can do that for both the first and the second term. In doing so, we get log of x squared plus log of y squared. The result that we have now, there is a sum in between. There's an addition sign. So I know if I have the sum of logs, this can be condensed to the log of a product. The product being multiplying x squared and y squared together. So our result is going to be the log of x squared, y squared. Now, if you wanted to, you could go one step further and simplify that argument just a little bit more. Since both factors, x and y, are being squared, we could write it as log of xy quantity squared, like this. So I think both of those answers could be acceptable. Let's go to example 2. 3 log x minus 2 log y. Again, with the 3 and the 2 being coefficients, I'll use the power rule backwards and make them the powers of each of the respective arguments. So I'll get log of x cubed minus the log of y squared. Because there's a subtraction sign in between these two log expressions, we're going to use the quotient rule in reverse and end up with a single log of a quotient. That will be the log of x cubed over y squared. And I really can't simplify that argument any further because the powers are different. We have a cubed on the top and a squared on the bottom. So this problem is fully condensed. Let's move to the next slide for some more challenging examples. So on this slide, we're going to do 3 examples of slightly more challenging condensing problems, starting with number 3. Condense log A minus log B plus log C. My first observation is that there are no coefficients in front of each log term, so there's not going to be any need for the power rule. So to start, I'm going to just look at the first 2 terms that I see when reading from left to right. And I've underlined those 2 terms in blue so you know exactly what I'm talking about. What we have here is the difference of logs, and the difference of logs can be condensed into the log of a quotient. So these 2 log expressions turn into, or is equivalent to, the log of A over B. So we've gone from having 3 terms down to 2 terms. So I'm going to look at the resulting 2 terms, which has a plus in between, and I know that the sum of logs is equivalent to the log of a product. The product in this case being A over B times C. And that product in the end will be AC over B. So our final answer will be the log of AC over B. So in the beginning, I had 3 terms with the word log, and in the end, I've condensed it to just a single term with the word log. So this has been fully condensed. Moving to example 4, we have the log of A minus the log of B minus the log of C. So 3 and 4 look really similar, except there are more negative terms in this problem than in number 3. Again, I'm going to start from the left and just go to the first two terms that I see. Log of a minus log of b. Because we have a difference of logs, this is equivalent to the log of a quotient, and that quotient would be a over b. Now I've gone from 3 terms with log down to 2 terms with log. And the operation between the two terms is subtraction, and I know that the difference of logs is equal to the log of a quotient again. Now this is where it gets a little challenging, because it's going to be a over b divided by c. Well, dividing by c is like multiplying by 1 over c. So in the end, we're going to get the log of a over bc. And I just want to highlight that that last transition is often problematic for students. It's tough. So just look out for it. Maybe rewind the video and watch it again, because that's usually where the pitfall happens, right there. And that, of course, is the international symbol for watch out, something bad could happen. Let's move to the last example, number 5. In number 5, we're asked to condense 1/2 log a minus 1/2 log b minus 1/2 log c minus 1/2 log d. There's a few different pathways I could take to get to the final answer, but I think the first thing that I'm going to do is use the power rule in reverse and allow all those 1/2s that are in front to become the power of a, b, c, and d. So we're going to end up getting log of a to the 1/2 minus log of b to the 1/2 minus log of c to the 1/2 minus log of d to the 1/2. Now, let's remember that raising something to the 1/2 power is the same as taking the square root. So I'm going to go ahead and just convert all of these into radicals or square roots. Now I'm going to scan through my 4 terms, and I'm just going to look at the first 2 that I see when reading from left to right. And what I have is a difference of logs, and a difference of logs turns into the log of a quotient. And this quotient will be root a over root b. Okay, so we've gone from 4 terms down to 3 terms. So again, I'm just going to pick the first 2 that I see from reading from left to right and work with that. So now I've got a difference of logs again, and a difference of logs turns into the log of a quotient. So we're going to have a division problem, and the age-old question will be, where does that root c end up? Is it going to end up on top with the root a, or is it going to end up in the denominator with root b? I'll give you a moment to think about it, and then I'm going to write the answer, and hopefully you guys got it right. Now we've gone from 3 terms down to 2 terms, and the 2 terms are separated with a minus, so we have a difference of logs, which is going to be the log of a quotient again. And when you have a quotient, you've got a division problem, and the question becomes, well, where does the root d go? So think about that. You've got another opportunity to kind of work on that division technique, and now I'm about to write the answer down. Because every single thing is under a square root symbol, I could really just write this as one ginormous square root symbol with all of those elements underneath, and I think I'm going to do that. I think this problem is actually done. It took a lot of steps. It was definitely the most challenging of all. We started out with 4 terms, each with the word log in it, and we ended up with a single term with the word log in it. So we're fully condensed here. So this video talked about condensing logs. Some of them are fairly basic, others of them are more challenging, but it's imperative that you know your 3 properties both forward and backwards so that you can successfully do this.